Let's talk about measurement and scale proportions. So given right here at the top left is your US customary system converted to your metric system. Remember, your numerators must match and so must your denominators, and if you ever see this symbol here, okay, it almost looks like an equal sign, but it's wavy. That means it's approximately or about. So let's look at a measurement example. Paige ran a 5-kilometer race. What should be the closest distance she ran in 5 miles? Okay, so it gives you the scale of 1 kilometer for 0.5 miles. Again, this is an approximation. Okay, so you want to use this scale given to you, okay, and equal it to what you want to find out. So for example, my kilometers are on top. So if I want to know how much 5 kilometers are, so 1 kilometer is equal to 0.5 miles. So 5 kilometers is equal to how many miles? So when I do my butterfly method, I'm going to get x, or 1x, equals 5 times 0.5 is going to be 2.5. So that means for every 5 kilometers, it's going to be approximately 2.5 miles. Let's try a scale example. A tree is 30 feet high and creates a 25-foot long shadow. At the same time, if a person casts a shadow that's 5 feet long, how tall is the person? So you've got your tree, which is 30 feet high, casts a shadow that's 25 feet long. Then you've got a person where you're trying to find the height and cast a shadow that's 5 feet long. You want to set up a proportion. So you have 30 feet high over 25 feet long. So when you set up your next ratio, you need to make sure the height is on the numerator and then the length is on the denominator. So you don't know the height, but the shadow is 5 feet long. You have your proportion. Use your butterfly method to solve. 25 times x is 25x. 30 times 5 is 150. Now divide each side by 25 because it's a one-step equation, and you're going to get 6 feet. So your person is going to be 6 feet tall. Let's try one more example. The happy birthday poster in Mrs. Cross's room is about 75 centimeters long. About how many inches long is the poster? Actually, let's cross this one out. Turn to the next page. In this page, it might not give you your full scale. For example, in number 2, Melissa's new puppy weighs 48 ounces. What is the puppy's weight in grams? So you need to refer back to your conversion chart to figure out that there is 1 ounce and 28.35 grams, and you can use this as your scale right here when converting ounces to grams. Turn one more page. Let's do some examples on scale proportion. In the first problem, it states a garage door that is 16 feet wide has this scale of 2 inches to 1 foot. So you want to figure out the scale of the door in inches. So I know my scale is 2 inches to 1 foot, and it tells me that the garage door is 16 feet wide. Since feet is in the denominator for the first fraction, feet needs to be in the denominator for the second fraction. Now you have your proportion. Do your butterfly method. X times 1 is 1x, or just x. 2 times 16 is 32. So the garage door is going to be 32 inches. Looking at problem 2. Chicago, Illinois and Mexico City, Mexico have a map distance of 10.9 centimeters. And here's your given scale. So I know my scale. I'm going to put that first. So it's going to be 1 centimeter to 250 kilometers. So now what I need to know, I have 10.9 centimeters. That's going to go in my numerator. How many kilometers is that? So I get 1 times x, which is 1x. 10.9 times 250, which is going to give me 2,725 kilometers. Let's try 3 and 4 together. A surgical instrument is 150 millimeters long. So here it gives us our scale. So I'm going to use that to write my first proportion. So I have 10 millimeters for every 1 centimeter. So my surgical instrument is 150 millimeters long. So that's my numerator. How many centimeters is that? 10 times x is 10x. 1 times 150 is 150. Divide each side by 10, and you get 15 centimeters. In problem 4, it says a lake is 85 feet across, and then it gives you your scale. I'm going to make my scale my first ratio, so it's 1 inch to every 4 feet. So then for my lake is 85 feet across. Feet goes in the denominator. And then my x will go in the numerator. 1 times 85 is 85. 4 times x is 4x. You have a one-step equation. Divide by 4 on each side. And you'll get 21.25 inches. Let's do some practice on measurement. Turn the page. Measurement is very similar to a scale. You want to set it up in a proportion and solve. So in example 1, or number 9, a girl who is 4 feet tall casts a shadow that is 3 feet long. At the same time, a flagpole casts a shadow that is 15 feet long. I like pictures. You don't have to draw them. So I have a flagpole that casts a shadow that's 15 feet long. It wants to know the height. You have a girl standing next to it that's 4 feet tall and casts a shadow that's 3 feet long. So when I set up my proportion, I'm going to put the picture where I have everything. That's my first ratio. So I'm going to say 4 feet tall over 3 feet long. So this is going to be tall over long. And so in your next ratio, you want to put the height of the flagpole first, which you don't know, and then the length of the flagpole next. If you wrote it with the length in the numerator and the height in the denominators, that is fine as long as you do that with both proportions. So now you do your butterfly method. 3 times x is 3x. 4 times 15 is 60. So you have a one-step equation and you want to divide each side by 3, and that should give you 20 feet. And this is 20 feet tall. Circle your answer. Remember, these are word problems. You cannot just put x equals 20. You have to label your answer. In the next example, a man who is 74 inches tall is standing next to a tree. The tree casts a shadow that is 80 inches, and the man casts a shadow that is 26 inches. How tall is the tree? So again, I like pictures to help. You don't have to draw them. So the tree, it tells you the tree casts a shadow that is 80 inches long, and it wants to know the height. Where the man standing next to it is 74 inches tall and casts a shadow, it says 26 inches. So my first ratio is going to be with the picture that I know everything. So I know the height and the shadow of the man. So 74 inches over 26 inches, and that's height over length of shadow. So then the height of the tree is x, the length of the shadow is 80. I want to set up my equation, which is going to be 26x equals 5,920. I'm going to divide both sides by 26, and I'm going to get 227 and 69 inches tall. That reads 227.69 inches tall. There are a couple different ways to set these up, so ask your teacher if you are setting them up a different way. Let's do 2 more together. A scale on a map is 1 inch equals 5 feet. So 1 inch equals 5 feet. The distance between the 2 points on the map are 8.5 inches apart on the map. Okay, so my inches goes in the numerator. When doing proportions, you can convert these to decimals. So 8.5 is going to be 8.5 inches over x feet. Do your butterfly method. 1 times x is x. 5 times 8.5 is going to give you 42.5 feet. 42.5 feet. Last example. The model replica of a building measures 5.2 inches tall, so it's 5.2 inches tall, and the width of the base is 1.6 inches. If the actual building is 280 meters tall, what is the actual base? So I know everything about my replica, so I'm going to say 52 inches tall over a base of 1.6 inches. Okay, so that's height over width. So when I write my new ratio, again, it's going to be height over width. I'm going to create my equation of 5.2x equals 448. I'm going to divide both sides by 5.2. You must show this work. You need to show the division. I'm running out of room. So that's going to be 86.15 meters, and that's the width. Oh, these should be meters. So it'll all be in meters. Okay. Ask your teacher if you have any questions. Finish the pages that we did not finish in the video.